Listen to part of a lecture in a chemistry class.
Today, I'd like to continue our exploration of the alkaline earth metals by talking about a certain type of metal that forms the common soda can. Soda cans are made of an aluminum-magnesium alloy. The magnesium is what gives the can its strength, and this use as an alloying agent is one of the most common applications of magnesium. It has a wide range of uses, though, from industrial to final consumption goods. The amount of magnesium produced and consumed has increased considerably since the 1960s. Today, worldwide production of magnesium is close to 600,000 tons. Now, the manufacturing processes that have made this level of production possible have also evolved. But basically, there are two main processes. The first uses electrolysis. Essentially, this involves passing electricity through elements that are fused or bonded together into compounds in order to separate them. As you know, metals and other elements are almost never found in their pure form. When you pass electricity through these compounds, it causes the elements to separate. The second process uses thermal reduction. Please understand that reduction is a chemistry term. It means to separate from impurities. This is achieved by using a reducing agent, a chemical that reduces metal from mineral ore. Actually, let's not get ahead of ourselves here. It's more important that you grasp the overall production process rather than the technical details, which you can pick up through your reading. Let's go into more detail about electrolysis. Can a metal such as magnesium be obtained from seawater? Yes, it can. The whole thing starts with seawater. We make a conducting solution by adding chemicals to the seawater. The solution is then refined, and then allowed to dry to obtain a solid piece of magnesium chloride. The solid is then melted down, and an electric current is passed through it to separate the two elements of the compound, the liquid magnesium and the chlorine gas. In the last stage, the liquid magnesium metal is further refined, and then it's processed for other uses. 1 pound of magnesium can be extracted for every 100 gallons of seawater. This may not sound like a good ratio, but seawater is plentiful, so you can imagine that there is almost a limitless supply of magnesium. But there's a catch. The electrolytic process requires 35 to 40 megawatts of electricity for every ton of magnesium. Can anyone conceptualize this figure? Well, 1 megawatt represents enough electrical capacity to supply 1,000 U.S. households with electricity for 1 month. So, for every ton of magnesium produced, you could power 35,000 to 40,000 households for a month. So, even when seawater is accessible, the electrical capacity of a country can be a barrier to magnesium production. The other method, thermal reduction process, this process allows almost any country to become a major producer of magnesium. For one, even though the total energy requirements are about the same as the electrolytic process, thermal reduction needs mainly heat energy. So, there are potential cost savings from using cheaper fuel sources, such as coal. The other advantage is that it allows all countries, even landlocked nations, countries without coasts, to become major magnesium producers, because the mineral ore containing magnesium is easily obtained from the Earth's crust. Magnesium is the 8th most abundant mineral and can be found in over 60 types of rocks. So, with the thermal reduction process, about 6 tons of ore is required to produce a ton of magnesium.